Greetings and welcome to the module 6 Chemical Shift. The objective of the session is to understand the term chemical shift, and the outcome of the session, at the end of the session, the learners will be able to define the chemical shift in a lucid way. Before going to the session, let us discuss the principle of NMR spectroscopy to understand the term chemical shift in an easy way. We all know that the energy levels of the protonic spins are degenerate in the absence of magnetic field. If we irradiate the magnetic field of around 2.35 Tesla, the energy levels are separated and they become non-degenerate. If the radio frequency radiation of 100 megahertz is irradiated to the nucleus, then the flipping of protonic spin takes place. This is the basic principle which we have seen in our previous modules. I repeat, the spin states in the nucleus are degenerate in the absence of magnetic field. If we irradiate the magnetic field strength of 2.35 Tesla, the spin states are splitted into low energy state and high energy state, to which if we irradiate the radio frequency radiation of 100 megahertz, then the flipping of protonic spins takes place. This is the basic principle. But not all the protons resonate at exactly 100 megahertz. I repeat, not all the protons resonate at exactly 100 megahertz. Question rises, why? Let us see why. Protons attached to the carbon atoms are surrounded by different electron densities compared with those attached to oxygen or nitrogen atoms. This affects their magnetic susceptibilities. The meaning is the protons, that is hydrogen atom attached to carbon, is having different electronic cloud then it is attached to oxygen or nitrogen, because electron present in the carbon, oxygen or nitrogen are completely different. Hence this affects their magnetic susceptibilities. Depending on their chemical environment, the precise resonance frequency of the proton will be shifted from 100 megahertz by a few parts per million. We name this phenomenon as chemical shift. I repeat, depending on their, that is hydrogen chemical environment, the precise resonance frequency will be shifted from 100 megahertz by a few parts per million, which we name as chemical shift. We can understand the term chemical shift with an example in our next slide. Consider the tertiary butyl alcohol. This is the structure of it. If you look at this structure, we are having totally 10 protons. As per the principle, all the 10 protons, if you irradiate the magnetic field, that will going to create at the energy levels. Then if we irradiate the radio frequency radiation of around 100 megahertz, the protonic flipping spins used to take place, but it is not happening due to the chemical environments of the atoms to which hydrogen is attached. If you see here, we are having one hydrogen is attached to the oxygen, whereas all the 9 remaining hydrogens are attached to carbon. So oxygen is electronegative, whereas carbon is electropositive, based on which we are having a difference in the precessional frequency of the protons. At 100 megahertz, we are supposed to get a peak, but we are not getting a peak. Rather, there is a shift of around 130 hertz, which is equal to 1.3 ppm, is shifted for 9 hydrogens of the methyl protons, and 400 hertz, that is 4 ppm, is shifted for the hydrogen connected to the oxygen. This shift is named as chemical shift. I repeat in short, at 100 megahertz, the precessional frequency of the proton is shifted to 130 hertz and 400 hertz for 9 methyl protons and 1 hydroxyl proton respectively, due to the chemical shift. So if you take in the proton NMR spectrum of tertiary butyl alcohol, the 9 methyl protons gives a signal at 1.3 ppm, that is 130 hertz higher in frequency than 100 megahertz, whereas hydroxyl proton signal is about 4 ppm, that is 400 hertz higher than 100 megahertz. Based on this, we can define the chemical shift as the difference between the resonance frequency of the observed protons and that of standard. We will going to learn what is the NMR standard in our next modules. The standard name is tetramethylsilane. And the chemical shift can be expressed in the formula: chemical shift delta sample is equal to precessional frequency of the sample minus precessional frequency of the reference divided by the frequency of the reference into 10 power 6 ppm. In short, the chemical shift is the difference between the resonance frequency of the observed protons to that of standard. The chemical shift is expressed in delta units, being the difference in frequency in ppm from the TMS signal. I hope you people have understood the term chemical shift. Thanks for your active participation. Kindly clarify your doubts by attending the online session in the Google Meet platform, which will be shared through WhatsApp group. Thank you.